I have a question for Andrea. We should have a GeoServer conference, like spending 2-3 days just doing presentations on GeoServer and technologies. It could be interesting. Anyway, now changing a bit of topic, I'm going to talk about the PyGeo API for geospatial data. And this is mainly a work done by Tom Kralidis. I also do a bit of help on some drivers and programming in Python. And well, what is this? So, in the beginning, there was WFS 2.0, and before that, there was 1, but let's ignore it for now. And it's WFS 2.0, basically uses some key value parameters or XML to do requests to the server. Requests are done using HTTP requests, like for example, you go to your browser, you put the URL, this is a GET request, or you send the XML in a post. You normally need the client to do this. Or even using this web service structure called SOAP that no one pays much attention or cares or implements. And also the response always tends to be in XML, which tends to be very verbose. And this is a typical example of a reply of an XML from a WFS, which is fine, defines here a feature collection that is bounded by an envelope, blah, blah, blah. Each feature then becomes very verbose, big XML. And we know, like Joachim's presentation, it can be very heavy. So we have an OGC standard that, let's call it issues, because it's like that, not bad, good, but it has some issues. So it's highly verbose, so it gets really big. Dependent on XML technologies, okay, we are in 2018, probably 5 years ago, everyone was only implementing XML, and you know how technologies go. XML is a bit, well, its use is not an issue with that, but people are preferring like things like JSON because it's lighter and easier to process. The documentation of WFS 2.0 is verbose, like 239 pages, which means like good sleeping literature. Like for me, this cannot sleep. So OGC document from 2010, like 80 years on IT is like 80 years on human life, because we have multiplied by 10 to get proper aging. And no unique URLs for the features. Basically, we have an XML, the features are there, and we simply cannot use a URL to point to these features. I'm going to explain these things. And one of the issues, because we don't have these URL structures, is that we cannot index things to search engines. So OGC and, let's say, Google's and Bing engines and Bang's whatever. What's the name of the one in China? Sorry, I always forget. So you cannot index data using search engine. This is a big issue. So continue a bit with the major issue that you cannot index things on search engines. There was technological solutions like LD proxies, where you have WFS services. You put the proxy on top and things more or less appear like in URLs or a REST interface. So at the end of the day, the OGC world until recently and the W3C consortium that rules the internet and controls the internet, they've been working a bit separately. So a new era is upon us. Currently on web services, we're using a lot of one thing called REST. I'm going to explain a bit better. Using these web services, the development tends to be faster than dealing with OGC, XMLs, and very heavy things. And so what is REST? It stands for Representational State Transfer, and it basically uses HTTP verbs on the standard itself. For example, first time I saw about REST was like something like 12 years ago. I was in a meeting in Switzerland. This North American guy comes and says, well, we don't like OGC, we use REST. And I was like, how can you do things? And then I had no idea what was a get, post, or delete, that even HTTP would support this sort of functionalities, because I only know HTTP like getting the URL from your browser. So REST uses the verbs to do actions in the server, and then according to the actions that you do, getting or adding things to the server, you get the code saying, yes, it was created, no, everything failed, or everything is fine. There's like a big list of codes, and also the advantage of having a REST, everything has a URL. So the issue that we had in WFS 2.0, where we have a big XML and we not so easy to go inside to each of the features, this is a bit avoided with REST. And also we find it a bit easier to negotiate content, meaning get me everything as a GeoJSON or XML, so it tends to be a bit easier. And it's stateless. The servers never know what happened before, what's going to happen in the future. Okay, so REST in the last years has been very, very popular among developers, mainly in the mobile phone development industry, because normally what you do is like you have an app and the app needs to get information from the server, so you implement a REST web service on the server. It tends to be very easy to understand. We use extensively JSONs on this sort of replies because it's light, easy to process. And the worst or the bad is that there's no rigid standards. When I was talking about HTTP verbs and codes, it tends to be anyone does more or less what it feels like that is correct. It may not be. So, in the beginning of the year, there was a hackathon by the OGC, sponsored by the OGC. They wanted to develop WFS 3.0, but they want to break the standard way that the OGC works. So the idea was to develop a standard based on Open API. I'm going to explain a bit more what is Open API. Writing the specification on GitHub. Let's avoid having a document going back and forth for a couple of years and writing 300 pages of documentation. And this happens in Fort Collins in the US, in the USGS, and some pictures of the hackathon. There was a lot of people there. Andreas was participating remotely. It was like in 2 days, goddammit, they had an implementation of WFS 3.0 in GeoServer. And Tom Karolidis was also remotely, and more people from around the world were participating. These were more or less the physical participants there. Yeah, typical hackathon. Unfortunately, one of the participants of the hackathon died some weeks ago. Unfortunately, Jivan, he was doing the Golang language client and server, unfortunately. Okay, so the thing is that in the internet is more or less monitored or controlled or decide the standards by the W3C consortium. And they issue now a document which is the best spatial practices for spatial data on the web. Basically, they refer that data has to be indexed, crawlable, and easy to access. This is a very good document. I recommend anyone doing web development to read this document, especially from the OGC side. And what is this Open API / Swagger? Because it was to know as Swagger. Well, it's a sort of standard way to define a REST web service. And it's also language agnostic. It has some very nice websites and tools, and is based in YAML syntax. And I'm going to show what is a bit YAML syntax. And then what we do is that we have REST endpoints, or how the web service works. We use this Open API to describe the web service. So the idea is that more or less, if you develop your own web service, you use this Open API to describe how things work, and this will help other developers understand your web service. So it tends to be very helpful. Here's, for example, this is more or less how a YAML file structure looks like. It's very simple. It's like properties, and then you put the text in front. And this is, for example, for describing get for a URL from the root URL from a web service. You know that using the verb get, we'll get some information about the description of a data set. And then as a response, if everything goes okay, you get like 200 HTTP and application JSON, GeoJSON. Getting a bit back to, this, to go back to WFS a bit, the specification is being written online, written as the YAML file format. So this, instead of having 239 pages of documentation, we just have this really small file simply describing some REST points. Go back. So for example, so what is that file describing? The file is describing WFS 3.0, that I come here to the Swagger Open API website, and it's going more or less to describe me how is a WFS 3.0. So the idea is, the idea on WFS 3.0 is simplicity to the maximum, and that's the thing. So we have a conformance endpoint where you simply go there and tells you more or less the metadata on the service. And the idea is that for every data set that you have in your system, it becomes a collection. And then from this collection / collection ID, which could be like countries, landmarks, potatoes, points of interest, whatever you want, you have each feature inside your data set, and this is another endpoint where you get this information, the feature itself from your data set. This is a bit like, so Andres had a very similar slide for this for open search with collections. This is it. This is basically the idea for WFS 3.0. It's like we have REST, we have 3-4 points of access, and that's it. Simple, I hope so. So I keep that, yeah. So again, the example, like you're going to have collections / countries / items / the Netherlands. So if I would have a service like this, I'll go to my URL, put all of these to the Netherlands, I would get a GeoJSON with a map of the Netherlands. As simple as it can get. So what's going on? The document of WFS 3.0 is being written live on GitHub. So there's people simply writing the document on GitHub and committing and issues and tickets, everything like it will be like a sort of live document. And this process simply shortened the type of development to, instead of years and years of discussion, just to a couple of days and comments. So currently, since 2-3 weeks ago, it's like OGC is looking for public comments of WFS 3.0. So we have to think that we started this process more or less as an hackathon in February. We are now in July and it's already for comment. Probably 6 months, 9 months, this could be like an official standard for OGC. Okay, finally, FOSS4GE2018. So what is FOSS4GE2018 related to the WFS I've been talking here? Basically, it's the pre-implementation of WFS 3.0. So it's everything prepared to have the API REST points. It simply uses development in Flask web frame that I like it a lot. And automatically generates documentation. For example, you saw there some REST access points, but we need to give names to these items, so everything is done automatically. We simply can plug into several data providers. We try to be very agnostic so that we're going to have a sort of plug-in system, can connect things. Currently, we can use this for drivers, for putting data on FOSS4GE2018 and then therefore having a WFS 3.0. We have Elasticsearch, common separated values, shapefile, no, SpatialLite, and GeoJSON. We are probably going to do now the Geo package, and I have there a suggestion to also use WFS 2.0 as a data source. Currently, the code is all sitting in GitHub on the GeoPython community. And we have things, the development reach a point where you have already Docker images. You can run all of this to test it on, 2 minutes. Oh, la, 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 la. Straight up. We have already the geocompositions done. I'm not going to show it here locally because I have another example. Okay. The thing is that in the Docker Hub, we have a composition for a single FOSS4GE2018 without Elasticsearch because Elasticsearch tends to be a very heavy system, and we decided to make two sorts of images, one simple, one more advanced. And I'm going to give you just, and this is an example of an implementation, the National Water Data Archive for Canada. It was done in a couple of days, installing FOSS4GE2018, putting Elasticsearch to work, getting the data there. And we have things like Elasticsearch in one server with 60 million features. And for getting each feature, we're getting something like in 100 milliseconds or 200 milliseconds was on the speed of the internet. But it's a system that goes extremely well and extremely nice. Let me see if I can. So this is just a feature coming out from the WFS 3.0 standard. From Elasticsearch, it has something like 60 million features inside. So the idea is that FOSS4GE API is very light, very simple to integrate, and then the data below the data provider simply leverage everything for us. Okay, future developments. More data providers. We're going to implement PostGIS, GeoPackage, support for OGR, also improve the code and functionality, because this is still a sort of beta. We're still testing things. And hopefully when WFS 3.0 comes out, we have a full prepared library with everything in place and just to have fun. Also implementation of SQL filters, and maybe then a bit more ahead for package for content negotiation, because now WFS 3.0 is heavily dependent on JSON. And later, with the implementation, they're going to have more extension encodings for GML and XML. So, another topic in parallel, there's also being developed a static catalog, is a sort of JSON catalog mainly for images. This works a bit similar with WFS 3.0. And the idea is also there's here in GitHub, and things are more or less scrollable, like we simply describe images inside the GeoJSONs, like the properties of a Landsat, and where are the resources related to this image, but in a sort of catalog way inside JSONs. This is going on work. They're working this a bit in parallel to WFS 3.0. It's very likely this could be integrated as an extension on WFS 3.0. Okay, finished. So I work for GeoCat, so if you need support for this sort of web services and GeoNetwork, of course, please contact us. And questions? No questions? Okay, lunchtime.
We go for lunch now. Oh, there's one question
jammer.
in the back.
Maximilian.
God damn it, there's always one.
Very simple. How do you pass filtering to the request?
We still don't have filtering.
The form? Oh, okay.
But it's going to be key value pairs, very likely, because there's already, the only thing we can pass is like the encoding. This goes by key value pairs.
In the URL as a GET request?
Yes. Okay. But for the SQL filters, of course, you have XML, and that is going to take a bit more programming, and you're going to have to see how this has to be implemented, because not part of the core of the standard. Yeah.
I only have a comment. The core specification has been kept very, very light.
Sorry.
Yeah, just a comment. The core WFS 3 specification has been kept very, very light, so you can only filter by bounding box and time, and then you can filter by attributes by equality, which is very limiting unless you have enumerable data attributes, right? But there will be lots of extensions, just like in WCS2, to handle more advanced functionality like reprojection, for example, which is not there.
No.
Filtering, like SQL filtering or whatever other type of filtering, they will be available as extensions. But the core is really something that you should be able to implement in a couple of days. So it has been kept like really, really light.
That's the idea of WFS 3.0.
Okay, so thanks for the presentation, and thanks to all presenters again. Enjoy the lunch break, and we see you back at 2 o'clock, not at 4, at 2.